Good evening everyone, I am Shafali Agarwal. I am a PMRF research scholar at IIT Madras, and today is our second last 11th session on the topic of basic construction material. So last week we talked about payments, and in this week you might have studied about wood. So an overview of what we talked about on woods in this week was, we talked about what are the different use and application of wood in our concrete studies, what is the structure of wood and how different elements of wood or how different orientation of wood will affect the properties of our wood or timber. Then we talked about shrinkage, how shrinkage happen in wood, and what is seasoning and what is the purpose of seasoning, and then what are the different mechanical properties, preservation techniques, and different products of wood which are used in construction industry. So basically, if we talked about different type of wood, we divide our wood in two type, hardwood and softwood. So these type of trees which we normally see in our plain areas, these consist of hardwood, and the type of trees you will see in hilly areas with these sharp needle like leaves, they are mainly consist of softwood. So second thing is, what are the different wood species in India. So So if we talk about what are the different species of wood in India, is we normally the most commonly used is teak wood. And what is the advantage of this type of wood is, it is have good durability as compared to other type of wood, and it's more stronger than other type of wood. Other type of wood is paddock wood. This is the type. This is a paddock wood, which is not much. You might have seen it have a very thin bark as compared to teak wood, and it has a medium density as compared to teak wood. Its density is lower. Other type of wood is rubber wood. You might have seen since childhood in books and all that we collect rubber from these type of woods. So it is very light hardwood. Its hardwood is very light as compared to other type of woods, and you can collect rubber or white liquid type rubber from this type of wood. Other is sal. This is sal wood, those white color trees and all you might have seen. So what is the advantages of this type of wood? It is very strong and it is very hard. Other is deodar, and then we have, this is deodar, and then we have rosewood. So in rosewood, it is very high strength wood, and its heartwood is of various colors. From here if you see, it is of pinkish color, so it can be golden brown or purplish or pinkish color. That is a rosewood. So next thing is, what is the structure of wood? So if this is your tree bark, if you cut your tree from this point and see from the top view, you will see some annual rings in this form, and this is a growth direction if you are seeing from this point of view. So these are different type of late wood, these annual rings are in this way. So what is happening when there is very rapid growth of cells, then we have this type of early wood forming. However, when there is a very dense growth of our rings, then it will form a late wood. So these are the two type of in annual rings we can see two type of structure, this early wood and late wood. So depending on how it is growing, if it is growing rapidly or if it is a slow growth, that type of structure will be formed in our annual rings. Other thing is if we talk about normal wood structure, so we have different parts of our wood. So if this is a complete cross sectional area of a wood, so starting from this point to this point, if we see, so this is a central axis, and then going along this direction, we have at the back we have the heartwood, like which is near to the center, and after that we have a sapwood, and at last we have the outer bark. So the part of the tree which we can easily take off, that is a outer bark. So here also it is written, it is a dead outer bark and inner living bark. So the one which you can easily remove is called as dead bark, and one which is not easily removed is called as live bark. And then in between this bark and the sapwood, we have a very thin layer of cambium. So what cambium will do is, it's useful for wood growth. So with years, when these annual rings will keep on increasing, so this cambium will help it to increase the growth of your wood. And other thing is like 3 different directions. So when we are coming from center to here, that is called as radial direction. If we are seeing our wood from the top view, that is a longitudinal direction, and from the side view, this view, it is a tangential direction. So these are the 3 direction of our wood. Other thing is, what are the different chemical composition of wood? So mainly our wood is formed of 50% of cellulose and 15 to 25% lignin and 23 to 30% of hemicellulose. So these are the 3 main components of our wood composition, and you might have studied their properties in the slides. It is given in details. You can go back and see those things. So if we talk about structure of wood, so we have a cellulose, and which is if we see in cellulose, if we will go from top to bottom. So we have a tree, then we are taking a bark of a tree. A bark of a tree will look like this, and then we have these circular rings which will tell about the year old, of how much year old our tree is. And if we take a part of it, so these are the annual rings we have, or we can say growth rings. And from this small part of your near to the growth ring, we have the cellular structure of our tree, of our inner bark, and then we can see that it is actually composing of a small cellulose. So maximum, as we talked about, 50% of cellulose will be there. So these type of cellulose will develop and form a normal bark of our tree. So this is mainly what we call it the structure of wood. Now we come to the different type of problems in our wood. First thing is knots. So what is happening when normally in a tree, if you cut any bark at that point or at that area, there is a chances that it will be very immature, or we can say it will be very live area. So some knots will be formed. So there will be high moisture at this point, and suddenly this area is exposed to the environment. So what will happen, there will be, like normally if we see in our human body also, if we have any injury, so something solid will be formed on that injury, because that area will be very soft. So same way a knot will be formed in an area where bark is cut from. So there are 2 type of knot, live or green knot, and then dead or loose knot. So the type of knot which is very solid and cannot be removed is called as live knot, and dead knot means it is very loose and can be easily removed. So basically how dead knots are formed, because the cadmium in this type of knot will be almost over. It will be a dead cadmium, and which will make this knot very hard and easy to be removed. So that is why we are calling as a dead knot. So as we have talked about, we have 3 direction of wood. Radial direction, when we are coming from center to corner or corner to center. When we are seeing from top, it is called as longitudinal direction, and from the side view it is called as tangential direction. So in these three direction, how different properties will affect. So if we talked about, first thing is shrinkage. So what is happening? Shrinkage along the tangential direction will be the highest, and along the longitudinal direction will be the lowest. So if you remember the definition of shrinkage, shrinkage means, anybody want to tell? So shrinkage means when there is a loss of water, how your material will shrink. Okay. So in case of tangential, if we see from this diagram, so in this direction your shrinkage will be maximum, and along the length your shrinkage will be minimum. So because of this shrinkage, what is happening, normally when shrinkage happen, your wood will warp, or there will be cracks forming in the normal wood or timber. Sorry. So these are the different problems because of shrinkage. Mildew. Dew means this drops. Because of mild drops, what is happening, this area of your wood is turning black, or it can be faded or grey. There are chances of cracks. Warping. Warping means it will bend in opposite direction. And then there are chances of splintering. Splintering means these rings are coming off, or some layers of wood will come off, and because of UV damage this will turn dark. Nail popping. Nail popping means you are trying to insert a nail and it will come off because of shrinkage. So shrinkage will happen, suddenly your nail, if there are joints or something, nail will come off. And last is cupping. Cupping means these will be very close to each other. So these are the defects because of shrinkage. Next topic is about the seasoning of wood. So normally in our wood we have a very high moisture content, and because of high moisture content during rainfall, or if we talk about shrinkage only, if our wood is exposed to environment too much, so this moisture will go off and there are chances of high shrinkage. So therefore what we are doing, we are seasoning it, or what we say, we are drying our wood before processing it. So we will dry our wood so that we are removing the excess moisture content from the wood and make it more durable and shrinkage proof. So what are the different type of seasoning? Mainly we have two type of seasoning, natural and artificial. So natural is, as in this case you can see, it is just kept one above another and left in the environment to dry, and a plastic sheet is above so that it is protected from rain and all. So this is one type of natural seasoning. So in this case we are not providing anything else, so it is called as air seasoning. So this is air seasoning. Other thing is water seasoning. So in water seasoning, what we are doing, we will immerse our wood in the water for a longer time and then we will dry it. So what happens in this case, if you are dipping it in water for a longer time, so all the holes and everything will be filled with water, and then when you are air drying it, so all type of moisture will be removed. But the disadvantage of this type of seasoning is, when you are dipping it in water, there are chances that some organic materials are also lost along the water. So this is a type of natural seasoning. Other is the artificial seasoning. In artificial seasoning, what we are doing, we are creating a chamber, in that we are stacking our wood, and then we are providing it different type, it also can be different type of seasoning. In this case we are providing heat to it, and there is fans, then steam, it can be steam, it can be normal heating, or it can be cool air. So that are the different type of artificial seasoning, and it is also called as kiln seasoning, because we are giving a kiln in which we are keeping our wood and then drying it out. So these are the different type of seasoning. The next thing is about the mechanical properties of our wood. So mainly if we talk about mechanical properties, we will talk about three type of properties: compression, tension and flexure. So if our wood is if a wood is lead to compression type of loading, so based on the different directions, so we have, this is our wood and this is radial, longitudinal, radial, longitudinal and transverse direction. So in which direction you are loading it, it will affect your properties of the wood. So in this case, if you see, it is loaded along the annual rings, along the direction of rings. So what is happening when you are compressing it, these rings, they are very strong, so they will bend and there will be a chances of sudden failure or cracking. So what is happening in this case, it is crushing the wood. So in this case it is crushing the wood, and in this case what is happening, the crack is not uniform, it is going along the weakest line. So that is called as wedge splitting. So it is forming a wedge kind of thing, so it is called as wedge splitting. Next is shearing. So in this case, when you have a crack or your failure is along any angle, in this case if 45-degree mostly, it is called as shear failure. And then if your crack is along the ring, mostly longitudinal type of thing, then it is called as splitting. So your wood is splitting in two parts, so that is called as splitting, and this is a type of crushing plus splitting. And lastly, it is a brooming or end rolling. So what is happening when you are applying compressive load, nothing is happening to the wood, but only the area where load is applied, that part is getting crushed, that is called as brooming or end rolling. So that are the different type of compression failure modes. So if we talk about our three directions, in three direction, if this is our axial direction, if we are loading it in the axial direction, what is happening? In this case there is a chances of failure, but as compared to tangential compression, it will be low. So maximum failure will be in tangential direction, then axial, and lastly radial. I told opposite. If you see from this diagram, stress strain curve, the compression of longitudinal direction will be highest, and then will be tensile or radial, it will be almost similar. So it will have compression in longitudinal direction will be, or axial direction will be the best, or it will be having the higher yield strength as compared to other two type of compressive failure. Why it is happening? So, if you see, if this is your axial direction, in this case if you are applying load, what firstly your annual rings will try to bend itself, and then only it will fail, as we have seen in the previous slide, different type of failure. But in this case, this is tangential compression. So in this case this will fail, these rings will fail. And in term of axial or longitudinal means you have one layer and above that another layer. So if this is a bark, and on this in this direction if you are loading it, what will happen, these different layers, it will compress, and there will be some gaps or something, so it won't before failure it can sustain more load. And in terms of radial direction, if this is our radial direction, in this direction if we are loading it in this direction, what will happen, again this will compress itself. So first it will compress and then only it will fail. So if you see from these three things, your longitudinal direction, your stress will be maximum. Okay. Next thing is in case of tension failure modes. So we are taking two direction along parallel to the grains and perpendicular to the grains. So in this case, which will have more chances of failure? So mostly in this case, what will happen, if we are loading in tensile in tension along the direction of grains, what will happen? There is a chance of brittle failure. However, if you are loading in perpendicular to the direction of grains, the type of failure will be more of tensile type of failure, or what you say, more tensile type of failure. So these are the different type of tensile failure modes in terms of wood. Last thing is flexure strength failure. So if in this case, if we are seeing along the grains, what will happen if you are applying it some flexure load? Firstly, your wood will split from the bottom, and then it will keep on splitting depending on the depending on the direction of your wood. So in this case, if you see the rings are in this direction, so it is splitting in this way. However, in here the rings are in angular direction, so it is splitting in this direction. Same way, the type of loading and amount of loading will affect your type of flexure failure. So if you see in these case, what is happening, these are the different type of failure modes that is given in your slides also. I will just repeat it once for you. So this is a simple tension failure, this is a cross grain tension failure, so along the grains it is happening, and this is a splitting tension failure, so it is splitting in two parts, that's why. And this is a normal tension failure, then this is a compression failure, and lastly this is a shear failure or horizontal shear failure. So these are the different flexure failure modes in terms of wood. Next is joints and connection. So when we are using our wood in our construction industry or in any for furniture and all, normally when we have to join them, we have to provide different type of joints. So that you might have studied in your first year engineering. We have lap joint, this is a type of lap joint, then we have butt joint, then these different type of joints we are reading. And then what we can use, we are using bolts, we are using rivets, we are using nails and all, and what can be the failure modes of these different type of joints and connections. So that is more or less, it is type of different joints and connection. Others are what are the what will happen when what type of failure can happen in our wooden structures. Mainly there are chances of bacterial attack on wood. So most popularly you might have seen termite attack in woods. It will eat up your wood in this way, and then there are chances of different ants getting into the wooden part, and or some fungal infection, fungal effect of fungal attack on wood. So they are the different type of problems which wooden structure will faces. Other are what are the different preservation techniques. So how to preserve your wood from these type of thing? Firstly, some superficial treatment. So that is like that is very expensive in nature, that's why we are not generally using this type of treatment. Other is liquid penetration. So what they are doing, they are they are adding some liquid to the wooden to the timber, and it can be added through pressure treating or through heat or through moisture. So keeping it in water or through injection grouting or something, we will provide the liquid penetration of treatment technique. And lastly, it is keep the wood dry. So more the moisture content, more are the chances of any type of attack on wood. And other part is keep the wood above the ground. So mostly termite attack will happen due to the coming of termites from soil. So if your wood is in direct contact with soil, there are chances of termite attack. So it is advisable that we should keep the wood above the ground. So last thing is what are the different type of wood products. So most commonly used is plywood. Plywood is also called as laminar type layer, thin sheet laminar I forgot that exact name. So it is also called as laminar type of timber or wood. So what is happening, they are taking it along the ring. It is being taken, very thin sheets are taken, and then these sheets are stacked together in different direction. Like one sheet will be in this direction, another will be in this direction, then this direction. So it will make it more compatible and more stronger as compared to normal solid wood. Other type of wood product is when we are using some particle or chips or strand boards. So these are like small particles of wood, they are compressed together to form these type of wooden material. So these you might have seen in like we used to have binding notebooks, cardboards and cardboard sheets. So these are used in cardboard sheets mostly. So these are the different type of wood which we are using as a furniture or in a day-to-day life. So this is all an overview of what you have studied in this week. If you have any doubt, you can ask, otherwise we will go for the question and answer. Okay, if there are no doubts, then we will see few questions. First question is, dash provides structure support, heartwood, sapwood or cambium? So if you see from this diagram, the heartwood is the oldest part of your tree. It will be very solid and very hard as compared to the sapwood and cambium. Cambium is just like a very thin layer of, it have very high moisture and it is used to make the new layers, and sapwood is like the younger wood. So the most solid wood which is providing the structure support will be heartwood. Okay. The monomer of cellulose is so the answer already given. So it's glucose, sucrose, hemicellulose or lignin. So the monomer of cellulose is usually glucose. Okay. Okay, so the third question is, annual growth rings in trees help in determining tree height, tree age, tree species or tree strength? B, correct answer. So the more the rings, you are telling it will tell about the age of your tree. Yeah, B, correct answer. Next question is, what is the main drawback of using wood in concrete structure? It have high compressive strength, it can have shrinkage and swelling due to moisture, it have high density, or there is chemical inertness. Anybody who want to? This is B. Yeah, correct answer. So because of moisture there are chances of shrinkage, swelling, then chemical attack. So this is the one of the main drawback of using wood in concrete structure. What type of wood is generally preferred for formwork in concrete construction? Softwood, hardwood, balsa wood or plywood? D, plywood. Correct. Normally for formwork we are using plywood. Why we are not using softwood or hardwood? Because as we have discussed in last slide of overview, that plywood would be much more stronger because of multi-layer of because of the one layer like this, one layer like this, one layer like this. So it will be much more stronger and it won't absorb moisture as much as hardwood or softwood. So that's why when we are using is formwork, we will use plywood. Next question is, what happens when wood is exposed to high moisture levels in concrete structure? It strengthens over time, it contracts and hardens, it swells and weakens, it remains unaffected. It's a very simple answer. What will happen when there is a too much moisture content in wood? See, yeah. So what will happen? It will swell and weakens the structure. So this is a diagram showing how much effect it can have. So when there is a moisture content, the swelling can cause this much change in the dimension of your wood, and it can weaken the structure. Which type of knot is tightly fixed and does not fall out easily? Loose, dead, live or encased? We talked about two type of knots. So which one is tightly fixed? So it is a live knot. So two type of knot we talked: dead knot and live knot. The one which doesn't fall off easily is called as live knot, and the one which is very loose, which have hardened over time, it called as dead knot. Okay, forgot to change, answer is C, live knot. Okay. How do knots impact the workability of wood in construction? It improves the nail and screw holding capacity. It makes the wood harder to saw and plane, increases the flexibility of wood, or have no significant impact. Any guess? B, make the wood harder to saw and plane. Correct. So these knots will be very hard as compared to the normal wood, and it will change the shape of the anvil rings also. So it will make the wood very hard to saw and to plane from that point of knot. Which of the following is the primary reason for wood's anisotropic nature? The presence of knots, directional arrangement of fibers, chemical composition, moisture content. So the answer is already given in the figure. So what do you think is the answer? Firstly, what is anisotropic nature? It means it have different properties in different direction. From that you can tell why it is anisotropic, because the directional arrangement of fiber is different. So in different direction you can have you will have different type of properties of wood. Like if you see from longitudinal point of view, you are seeing all the rings from the top view, right? In tangential you are seeing it along the ring, and in radial your rings are perpendicular to your direction. So because of different direction you have different you can say it is an isotropic nature, anisotropic. Next question is, which property is or are most affected by the anisotropic nature of wood? Hardness, thermal expansion, strength, electrical conductivity or shrinkage? E, shrinkage. Any other property do you think will be affected by the nature of wood? So shrinkage is the correct answer. Along with shrinkage, as we discussed, even the strength will change along the different direction. So the most affected properties will be strength and shrinkage. Okay, so this is the diagram for shrinkage. We have seen that in tangential direction the shrinkage is maximum and longitudinal it is minimum. Same way for the strength, we talked about how in axial direction it will be higher strength as compared to radial and tangential. Okay. Which of the following is the weakest direction for wood under stress? Longitudinal direction, radial direction, tangential, or all direction? Okay, C, tangential direction. So C is the correct answer. So if you see from this point of view, why weakest direction is tangential direction? If you are applying load in this direction, you are applying load in the perpendicular direction to the grains, and there are chances of grain breaking and a sudden brittle failure of your wood. What is the primary purpose of seasoning the wood? To make it heavier, to increase its moisture content, to reduce the moisture content and improve durability, or to change its color? Why we are doing seasoning? Anyone? So seasoning of wood means to reduce the moisture content and to improve the durability. So two type of seasoning we talked about, natural and artificial, right? Which of the following defects can occur due to improper seasoning? Warping, cracking, shrinkage, or all of the above? So if there is D, correct. So if there is improper seasoning, that means you have a very high moisture content in your wood and it will lead to shrinkage, and shrinkage can further lead to warping and cracking. The answer is D. Next question is, what is the fiber saturation point in wood seasoning? The point where all free water is removed but bound water remains, the moisture content at which wood is completely dry, the point where bound water and free water are equal, point where wood cannot absorb any more moisture. A. Yeah. So the fiber saturation point is when completely free water is removed and only bound water remains. That is called as fiber saturation point. Next question is, what is the primary mode of failure in wood under compression perpendicular to the grain? Fiber buckling, splitting, densification, or shear cracking? So if we see the diagram, if along the grain, perpendicular to the grain, if there is compression, what is happening? Buckling, splitting, densification, or shear cracking? So if you see for this figure, if we are compressing it in this direction, there are, firstly what will happen, these will come closer to each other. So first it will be densification of fibers. Okay. Okay, so the next question is, why is wood generally weaker in tension perpendicular to the grain? Wood fibers are not continuous in this direction. The lignin content is higher. It absorbs more moisture in this direction. Tensile forces improve fiber bonding. from figure, if you see what is happening, if we are applying tensile load along this direction, along perpendicular to the grain, there are maximum failure is happening along the grain only. This is shear failure, tensile failure. So this is because of wood fibers being not continuous in this direction. So A is the correct answer. Next question is, which part of a wooden beam under bending stresses experiences the highest tensile forces? Top fibers, bottom fibers, neutral axis or shear zone? B, bottom fiber, correct answer. So whenever there is a bending load applied, the highest tensile forces will be at the bottom fiber of your wooden beam. Which of the following fastener is most suitable for transferring shear forces in wooden connection? Nails, screws, bolts or adhesive bonding? Any guesses? A, nails. Okay, so mostly when we are talking about shear force, we cannot provide nails, we will provide bolts in this case. Why we are providing bolts is like, if you see from this point of view, if you are providing nail, if there is a normal nail in this case and there is a shear failure, what will happen, this nail will tear off the wood and it will go like this. So there are chances that it will tear off your wood from this point. That's why we are not providing nails. Okay. Second thing is about screws. So screws also same problem. If you are providing screws, there are chances of tearing of the wood from this point. Okay. And bolts, in case of bolts, what we are doing is we are providing a hole and then we are providing a bolt and connection, right? So what will happen, even if there is a shear force applied in this case, there won't be any tearing or something. It will be much more stronger bond as compared to other type of connections, because it will be from the complete length, first thing. Secondly, you are creating a hole, so you are reducing the stress concentration, whereas in case of nails or screws, you are just you are nailing it or you are hammering it, so there will be a high stress concentration in case of nail, because the edge will be very pointy. And lastly, if we talk about adhesive bonding, so adhesive bonding, it is very easy to remove adhesive bonding when it comes to the shear forces. So that's why we are telling bolts will be the best type of fastener in terms of shear strengthening. Okay. So next question is, which factor makes wood more susceptible to insect attack? High density, high moisture content, low resin content or chemical treatment? Anyone? So as we talked since start of lecture, we are talking that if we have a higher moisture content, the maximum type of failure will happen in wood because of high moisture content. So if you have high moisture content, your wood will be more susceptible to insect attack. Okay. The last question is, which property of plywood prevent it from warping compared to solid wood? High density, cross grain orientation of Venus, use of synthetic adhesive, high moisture content. So obviously we don't have high moisture content in case of plywood, so this is the wrong answer. So what do you think is the correct answer from A, B and C? So because of cross grain orientation, so one layer will be in this way, second layer will be in this way, then again third layer in this way. Because of this type of structure of your wood, even if you have shrinkage failure or any type of failure, it won't warp or it won't bend because of this type of orientation. Okay, so that's all for this week. If you guys have any doubt, you can ask me now. Assignment 10, question number 5. Just 2 minutes, I will open. Select the inappropriate option regarding the rigid pavement from the following. A drainage course is not required in rigid pavement because of less permeability. Reinforced concrete pavement doesn't require expensive joints. The suitability of concrete is decided on compressive strength but not on tensile strength. Fiber reinforced reduces the thickness requirement of rigid pavement. Yeah, so what is your doubt? Yash, can you type your doubt or you can speak up also if you want. So, okay, I will just explain in journal. First option, drainage course is not required in rigid pavement because of less permeability. So, this is a true. Reinforced one doesn't require joints. It is correct. Yeah, it is correct. So, we have to choose the incorrect option. Okay, wait. Rigid pavement doesn't require expansion joint. Yeah, so this is a wrong statement only, right? Normally in reinforced concrete pavement, we will provide joints. If you remember my previous slide, we were talking about in rigid pavement, there are chances of expansion due to heat, and even there are chances of shrinkage and expansion because of presence of concrete. So in that cases we actually provide expansion joints. So that's why this statement is wrong.
But the third one is also
Third statement.
third one.
The suitability of concrete is decided on compressive strength but not on tensile strength.
In the lecture, I remember sir told that it is decided on tensile strength.
No. For payments, you won't decide on tensile strength because how I will explain. So in case of payment, if it case of payment, the mostly we it lead to compressive strength only. Compressive failure only. It doesn't lead to tensile failure. From diagram how. So if you talk about loading, mostly loading will be in this direction, right? We have wheel loads at the top and then we have soil loading from the bottom. So main type of failure in this case will be compressive. Yeah, tensile failure will be in this direction, right? But in this direction also there will be shoulder will be provided and it will be holded properly because we are talking about rigid payment. So rigid payment, we want light rigid payment in general, as in we are providing our normal bitumen payment. So in rigid payment it will be kind of fully it will be a type of slab only. So in slab, if you see your slab will be holded in 4 directions. So most of the failure type of chances will be compressive failure, not in tensile direction. Is it clear?
But for this second option, it is given in the lecture slides also that we don't require joint. This concrete pavement slabs need to be jointed except when continuous reinforcement is provided. It is mentioned in this lecture slide.
Second option you are telling in expansion jointing.
Yes.
No, when you are providing concrete payment, usually it will be a long payments. So you will provide joints in that case. It can be small joint also. Sometimes you will just provide a type of slit kind of thing, or it can be a full joint with double bars or something. But you will provide joint in reinforced concrete pavement for sure. It may not be, maybe this expansion joint is what is expansion word is not correct, but joints should be there for sure in your concrete pavements. So not necessarily that you are providing joints in the expansion area only, but for RC pavements we will provide joints.
And in non-reinforced one, we provide in both directions double cuts.
No, double bars we were providing RC structures only, RC payments only. It's like in RC payments we talked about two type of. You are telling about in continuous type of RC payments, right? In continuous rigid payments, we say that we are not providing joints. So in that case, what we are doing, as I told you, we will provide a slit. like after a complete payment is laid down, we will provide some slit to give it type of expansion joint only. It won't be a joint full joint as we are providing in slab kind of payments, but there will be a slit or joint. So maybe this statement, the way this statement is said is wrong, but in case of RC design, we will always provide a small joint in between the different after some time.
And when we will provide the down joint?
When we are not providing complete reinforced sorry, oh okay, okay, in slide it was told that in complete RC payments we are not providing expansion joints, and in case of only concrete payments we will provide expansion joints and dowel bars. Okay, so the statement is wrong. Fine. Okay, I will talk change the statement. I will talk to these people at NPTEL. I will try to change the statement. I understood your point too. So generally in RC payments we discussed that we are not providing expansion joints as particularly like a dowel bars or something. So yeah, that will be a wrong option in it.
But actually we do provide.
We will provide joint, but it won't be with double bars or something. Okay, any other doubt? Okay, if there are no more doubts, then we will close the class for today, and most probably there will be a live session by Professor Munasandhanam by within next 2 weeks before your examination. So we will inform you through, like, NPTEL team will inform you on the exact date. So if you guys have any doubt to ask him, you can write it down or something. Okay, thank you for joining.